All right, so lesson 2.7, primarily dealing with rate of change here, right? So always remember, is the change in y over the change in x. Okay, that's your rate of change. And when you asked to describe, you'd say, you know, you're increasing or you're gaining, right? This many units for every whatever x is, right? So 100 kilometers per hour, right? Like if you do the math, you see 100 kilometers in an hour. It's like, well, you're traveling 100 kilometers every hour, basically, right? So here we have a hot tub contains 1600 liters of water. Graph A, which is this one here, represents a hot tub being filled at a constant rate. So you're filling it. Graph B represents a hot tub being emptied at a constant rate. So identify the independent and dependent variables. So you look at the graphs, right? Your independent always goes along the x, your dependent always goes along the y, right? So T is independent variable and V for volume, right? The dependent variable. Okay, so we've stated that. Determine the rate of change of each relation and describe what it represents. Okay, so the bottom line here is you need to pick any 2 points. We know that these are linear, right? The graph tells us they're linear, so we're not checking for whether or not these are linear. It's a linear relation. We know that. So now we just need to find the rate of change. So I'm going to zoom into one graph at a time here. So what do we notice about the two graphs? Well, from left to right, this one is increasing. From left to right, if you read this graph, you are decreasing. So that's something that I need you to understand. When you read a graph from left to right, just like you read a book, just like we read anything, right? If you read this graph from left to right, you'd have to say that you're increasing. If you're reading this from left to right, you'd have to say that you are decreasing. So you have to keep that in mind because you're going to see something at the end in terms of our answers. Okay. So I'm just going to zoom into one a bit more because I'm going to work with the left with graph A first. So you want to pick any 2 points along this line. Now you have to be smart about it. Okay. Picking that point right there, not smart because you're right in between these two values here. You want to pick one where the grid intersects. The x and the y is intersecting here exactly. This would be a good point. I already highlighted it. It's usually not going to be given, so but we're going to pick that one and keep traveling. You could pick this one here, keep traveling. I'm going to pick this one up here because it's also somewhat highlighted. And we're going to call this A and B, right? That point right there. Let's write down the coordinates. The coordinates of this one right here would be 4,800, right? So you write down 4,800. And the coordinates of the second point would be 80, 1,600, right? So those are your 2 points on that graph. Okay, let me see if I can focus a bit more there. So you've got that going on. And so to determine the rate of change, again, I'm just going to do this one more time because it's crucial. It's the change in the y or dependent and the change in the x independent. What is change? Well, change is how much have you increased or decreased from one to the other. Okay, so that's how you do this. And what I need you to understand here is that we're always going to take the rightmost point and subtract the left point from the right. Okay, so if you look at this one is to the right, this one is to the left. Okay, so we're gonna go always right minus left when we do the math to be consistent. Okay, so rate of change. Let's look at our y values. This is the rightmost point, so we're going to go 1600 minus it's 800 to the left. So the change in your dependent variable is found by doing this. The change in your x variable is you're going to go to the rightmost point, subtract from the leftmost. So we're subtracting the y values and we're subtracting the x values, but always taking the right first, then the left. So rate of change is going to be 800. And what is that 800? What are we dealing with? We're dealing with liters in the dependent variable. So you have to include the units there. Rate of change here, 80 minus 40, that's obviously 40. And we're dealing with minutes. So you put minutes down here. Make sure rate of change, you have your units figured out. Okay. Now, let's just for 1 second stop here and just look at our graph. 800, where would that, how could we view that here? It's the change in the dependent. That is this right here. If you were to travel straight up and just consider, right, where you start here at 800, you go to 1600, 800 liters it has increased, in fact, by 800 liters. And then if you go from here to there, from this corner to there, just go down for a second here, 40 and 80, it has 40 minutes have gone by during the 800 liters increase. Okay, so you can actually see the rate of change right here. It's comparing the vertical over the horizontal, or the change in dependent over the change in the independent variable. We can now reduce this, right? Reduce, don't forget that. So rate of change, we can cancel out the trailing zeros, so it's 80 over 4. 4 goes in there 20 times and goes in there 1 time. So we write this like this, watch, 20 liters per minute. Like that's how we want to state it at the end. So what does that mean? What does this mean? Well, since it's positive, by the way, since this is positive, it's increasing, right? So there's a 20 liter increase for every minute that has gone by, okay? So we could say that 20 liters of water have been added for every minute gone by. Okay, this is the explanation of what does that mean. Like for every minute you're adding 20 liters. That's, you could have worded it that way as well. Okay, but I actually say it the way it is. 20 liters of water have been added for every minute gone by. Okay, now let's go over to the other scenario. Okay, what's happening here? Oh, let me just, you might have asked, Mr. Jackson, why didn't you use 0, 0? Could I have used 0, 0 and let's say this point out here? Yes, you could have. Yes, you could have. And we will do that a little bit more later on. Could you have picked this point right here and this point and call it A and B? Yes, you could have. Yeah, you could have. So it doesn't matter which 2 points, if they're all the way further apart here, or if you're picking these two, or if you're picking these two, it doesn't matter. You could have picked this one right here and that one. When you reduce it, Okay, if you do this right and you reduce it, you all should still get the same answer. Okay, so the key is in doing the work properly, and then you'll get there. I do not recommend picking 0, 0 because down the road it's not always going to be at 0, 0, and so that can cause some issues. It's easier, but it will cause some issues down the road. All right, graph B. We talked about that this one is going down, it's decreasing. Let's pick 2 points. So if we pick this one right here, that's point A. This one right here, that's point B. Okay. So again, we're asked to find the rate of change. That's the change in Y over change in X. So rate of change. Let's see here. Let's come up with the coordinates first. This point right here, that would be 20, 800. This point right here would be 0, 1600. Okay, those are the coordinates. Which one is the point that's most to the right? It's this one right here. So that's the one you start with. So the y values, right, you got to go 800 minus 1600. And then here you have to go 20 minus 0. And that's going to give you negative 800, and remember it's liters, over 20 minutes. Okay, so our rate of change is that. Can we reduce it? Yes. So rate of change, it's going to be, if you cancel the zeros, you're 80 over 2, that's obviously 40, right? 40 liters per minute. And that's your rate of change. You can say that 40 liters of water is being drained for every minute gone by. Now, 40 liters have been removed, if you like to say, or the amount of water is decreasing by 40 liters every minute. All of those are valid ways of describing what's going on. Okay, you just have to, it has to make sense within the context. If it makes sense, then you're good. Right? Okay, so I'm going to stop this as well, and we're going to do that example 4 on a separate video because I know it's going to run. We're going to run out of time.